Hi friends, this is Akshay Shaji, third year Tivoli, signing up for you from Dr. Mahalingam College of Engineering and Technology with a schematic method of solving a given mechanical system and steps involved in converting it to an analogous electrical system. Mathematical modeling and hence transfer function for every given system is very necessary in order to study the system. In order to avoid the difficulties faced in solving an electrical system, we go for conversion of electrical to mechanical system, solving it in mechanical terms and writing the equivalent force voltage and force current analogous equation for it. In this system, we have two masses M1 and M2. And M1 and M2 are connected to each other via a spring K2 and a damper D2. M1 is connected to the external support via a spring K1 and a damper D1. And M2 as well is connected using a spring K3 and a damper D3. The force acting on M1 is given as F1 and the displacement due to F1 is X1. And similarly, the force acting on M2 is F2 and the displacement is X2. Let us make the explanation so simple. Let us do it in a step-by-step manner. The first step is step 1. Identifying the nodes, and drawing the free body diagram. The nodes here are mass M1 and M2. So let us draw the nodes. M1 and M2. The forces acting on M1 are the applied force F1, the opposing force due to the mass Fm1, the opposing force due to the spring Fk1, the opposing force due to the damper Fd1, the opposing force due to the other spring Fk2, and the opposing force due to this damper Fd2. In similar manner, for mass M2, it will be the applied force F2 and the opposing forces are Fm2 in this direction and Fk3 in this direction and Fd3 in the other direction, Fd2 in the other direction and Fk2 in the opposing direction. Step 2. Writing the force balanced equation from the above step. A force balanced equation should consist of all forces acting on the node. The opposing forces will be in the opposite direction as of the applied force. Therefore, the force balanced equation for the first node will be F1 is equal to on a side and Fm1 plus Fk1 plus Fg1 plus Fd2 plus Fk2 on the other side. And in similar manner, for the node 2, it will be F2 is equal to Fm2 plus Fd2 plus Fk2 plus Fd3 plus Fk3. Step 3. Expanding the force balanced equation in terms of displacement. Therefore, the force F1 is equal to, for mass it is m1 into d square into the displacement in that node, that is d square x1 divided by the time dt square, plus for k1 it will be k1 into x1. For d1 it will be d1 into dx1 divided by dt. But in case of d2 and k2, they are the connectors between the two nodes. So both the displacements comes into picture. So that becomes plus d2 into d times x1 minus x2 divided by dt. And for k2, it will be plus k2 into x1 minus x2. And similarly for force F2, it becomes m2 into d square x2 divided by dt square plus, now for d2 it is as same as in this case, but the polarity changes. Therefore it becomes d2 into d times of x2 minus x1 divided by dt. plus for K2, in similar way the polarity changes. It becomes K2 into x2 minus x1. And for D3 it is plus D3 into dx2 divided by dt. And for K3 it is plus K3 into x2. The step 4 intends in writing the same equation in terms of velocity. Therefore, as we know, this is in terms of displacement. To convert it into velocity, we reduce the derivated terms in one order. Therefore, it becomes m1 into dv divided by dt. And similarly, for the spring term, it becomes k1 into integral of v dt. And therefore, the damper, it becomes d1 into v1. And keeping this in mind, we are now going to derive the equations in terms of velocity. Now the step 4. Writing the above equation in terms of velocity, it becomes F1 is equal to m1 into dv1 divided by dt plus k1 into integral v1 dt plus d1 into v1 plus d2 into v1 minus v2 plus k2 integral v1 minus v2 into dt. Similarly, F2 becomes m2 into dv2 divided by dt plus d2 into v2 minus v1 plus k2 integral of v2 minus v1 into dt plus d3 into v2 plus k3 integral of v2 dt. Now let us study the analogy. Before doing step 5, we need to know what is the analogous terms for the given mechanical terms. So let us draw an analogy table. Let us have on left hand side the mechanical system and on right side the electrical system. Here the electrical system refers to force voltage analogy. So therefore here the force is replaced using voltage and the displacement x is replaced using current I. And therefore let us now consider a damper. A damper consists of a force applied to it and the damping constant d, and this system has a let it have a displacement of x. Therefore this is replaced using an electrical circuit consisting of a resistor R to which a voltage E is applied and the current I flows through it. The equation for a damper is, in terms of velocity, it is d into v, and for the equation F is equal to d into v, and therefore the equation for a resistor is E is equal to IR. And similarly for a spring, the constant K and a force F applied to give a displacement x, and this is replaced in an electrical system using a capacitor to which a voltage is applied. And a current I flows through it, and the equation becomes, here it is K into integral of V dt, and here for voltage equation it is E is equal to 1 by C integral of I dt. Now the last thing is the mass. For a given mass, a force F is applied and a displacement x is produced, and therefore this is analogous to an inductor, and a voltage is applied and the current I flows through it. The equation for a mass is m dV divided by dt is equal to F, and the voltage equation here becomes E is equal to L di divided by dt. Let us close the analogy table. Step 5. Drawing the analogous electrical circuit for the given mechanical system. Before that, let us see what all are present in the given mechanical system. As we have seen already, there is a mass m1 and another mass m2. So these are going to be replaced according to the analogy using an inductor. Therefore, let us now draw the circuit. The supply voltage E1 replaces the force F1. Therefore, the elements which are directly connected to F1 will be the mass M1, an inductor L1, and the other things are a spring K1 and a damper D1. Therefore, the spring is going to be replaced by a capacitor C1, and the damper is going to be replaced by a resistor R1. Now, the connecting elements K2 and D2 are going to be in parallel with the circuit. Therefore, with the supply voltage. Therefore, they are going to be replaced again. Therefore, K2 will be replaced by C2 and D2 will be replaced by R2. Now, similarly, for node 2, it becomes an L2, a C3 and an R3, and here a force is acting, and let the force be E2. Let us now close the circuit diagram. And the current inside will be I1 and I2. And the force is acting upwards and this force is acting downwards. Step 6. Writing the mesh equation for the given two loops. Therefore, for loop 1, here the applied force is being replaced by the applied voltage. Therefore, E1 is equal to, for the given inductor L1, it becomes L1 di1 divided by dt. And for the capacitor it is plus 1 by C1 into integral di into I1 into dt. And for given resistor, it is equal to plus I1 into R1. And for the common nodes, it becomes plus 1 by C2 integral of I1 minus I2 into dt. And for the R2, it is R2 into I1 minus I2. Similarly, for loop 2, it becomes E2 is equal to L2 into di2 divided by dt plus 1 by C3 integral of I2 into dt plus I2 into R3 plus C2. Here it becomes, for C2 it is 1 by C2 into, don't repeat this mistake, it is 1 by C2 into integral of I2 minus I1 into dt plus R2 into I2 minus I1. With this, our sum is over. Let us now check for clarity. Now, in this loop equation, all the terms must be equivalent to the terms which we wrote for in terms of velocity in the mechanical system. Now, E1 is equivalent to F1 and L1 di1 divided by dt. L1 corresponds to mass m1. Therefore, let us search for the term for mass m1. In this, the term for mass m1 is m1 into dv1 by dt. There it is L1 into di1 divided by dt. And next it is 1 by c1 integral of I1 into dt. The similar term in the other equation is k1 integral of v1 into dt. And the next term is I1 into R1. The similar term in the other equation is D1 into V1. And the next term is 1 by C2 integral of I1 minus I2 into dt. And here it is K2 integral of V1 minus V2 into dt. And the next thing is R2 into I1 minus I2. And here it is D2 into V1 minus V2. And the loop 2 could be checked by yourself. This is Akshay Shaji signing off from this tutorial. Let us watch again with yet another interesting video. Thank you.